Lesson number 2, gravimetric stoichiometry. So in gravimetric stoich, we are using a mass of a reactant or a product to determine a mass of something else in our chemical equation. It's always a mass-to-mass relationship. Steps for gravimetric stoich and all other stoichiometry, it's all the same. There's just some variation in how we solve for our wanted information. And so really, if you get in the habit of practicing the same way, it becomes very, very easy. So step number 1 is writing the balanced chemical equation. We're going to do this for the reaction between oxygen and propane. We have propane, C3H8 gas, which is reacting with oxygen gas. It's going to produce carbon dioxide and water. We need to balance this chemical equation. So the rule for combustion reactions is carbon, then hydrogen, then oxygen. Starting with my carbons, I see I have 3 carbons over here, so I need to put a coefficient of 3 in front of my carbon dioxide. Moving on to hydrogens, I have 8 hydrogens. I need to put a coefficient of 4 in front of my hydrogens. Now I have to total up my oxygens. 3 times 2 gives me 6 oxygens, and 4 times 1 gives me 4 oxygens, which gives me a total of 10. Over here, I need to put a 5 because 5 times 2 is also equal to 10. So we have a balanced chemical equation. Now we can move on to step 2. Let me get rid of all this extra stuff here. All right, so step 2, determine the given and wanted information. Determine the mass of oxygen. Is that my given information or my wanted information? That would be wanted. That's what we want to figure out in the end. Next, reading on, we have to completely burn 15 grams of propane. There is my given information. And so I have a mass of 15.0 grams. And then I should also determine its molar mass. Molar mass is equal to 44.11 grams per mole. That's determined by using the molar mass of carbon, 12.01, multiplying by 3, and the molar mass of hydrogen, 1.01 multiplying by 8, adding those two together gives you 44.11. For oxygen, we have a mass that we're trying to figure out, so that's our wanted information. The molar mass of oxygen is 16.00 times 2, which is 32.00 grams per mole. So that right there is step 2, given and wanted information. Step 1, step 2. Now, step 3, 4, and 5 are all done together in one equation using unit analysis. All right, so we're going to start by using the measured quantity of the given amount. So that's our 15.0 grams. And to keep ourselves organized, we're going to call it what it is, of propane. We are going to multiply by something to get rid of grams of propane and replace with moles of propane. And this is our molar mass, which is 44.11 grams. So the 44.11 goes on the bottom because that's where the grams are. Per 1 mole goes on the top. Now we need to multiply by something to get rid of moles of propane and replace with our moles of our wanted, which is oxygen. And so then we go to our mole ratio and we look, and our moles of our wanted is 5. Our moles of our given is 1. So we have 1 mole of propane and 5 moles of oxygen. Finally, we have to get rid of moles of oxygen and replace with grams of oxygen, and we're back to molar mass, which is 32.00 grams. Now that number goes on top, 32.00 grams per 1 mole. Taking out your calculator, multiplying 15 by 1 divided by 44, or just dividing by 44.11, then multiplying by 5 and multiplying by 32 gives you a final answer of 54 54.4 grams of O2. Now, step 6 is our statement answer. We always have to finish with a statement giving what we just figured out. So it can go a couple of ways, and one way that we can look at it is like this. To burn 15.0 grams of propane, you need 54.4 grams of oxygen. And that would be a acceptable statement. Gravimetric Stoich, done the same way every time. Balanced chemical equation, determining given and wanted, step 2. Step 3 is start with a measured quantity and determine moles. So this right here is step 3. And then use the mole ratio. So this right here is step 4. And then determine the mass of wanted. This is step 5, using the molar mass. So step 3, 4, 5. And then finally we have step 6 down here, our statement answer. I'm going to give you 2 more examples to try with solutions that will be provided after you pause the video, give it a go yourself, then check the solution. So example 1, 2.35 grams of silver nitrate will be dissolved in water and reacted with iron 2 sulfate solution. Determine the mass of the precipitate. Remember, a precipitate is a solid product from 2 aqueous solutions. All right, so that's example number 1. Give that one a go. The solution will be up shortly. Have a look at the solution and see if yours matches, and if it doesn't, try and figure out where you went wrong. And then we'll move on to example 2. Example 2 is similar in terms of the compounds we're using. We're removing silver from the silver nitrate solution using excess copper metal. Determine the amount of copper used if 3.17 grams of silver was collected after the reaction was complete. Again, take a minute, work your way through the problem. The solution will be up in just a second. All right, so solution number 2 is as seen here. One thing that is very common, especially when you get to assessments, is not knowing which copper ion to use and then going with the copper 1 ion because it's easier, because then it would be a 1-to-1 ratio. But we always have to use the most common charge. So make sure whenever you have a multivalent metal, a metal that has multiple charges, you choose the most common one. And that's the one that's listed first on your data table. So we would use copper 2 in this case, not copper 1. Practice the gravimetric Stoich questions from your workbook. There's a whole ton of them, and it's really important that you get good at not only writing the balanced chemical equations, but then solving those gravimetric Stoich questions efficiently. It'll set you up for success moving forward.